Okay, I think I've got it working. Thank God. That took way too long. Hopefully people find this. I might just send on here, where is it, where is it, where is it? Uh, Stalking, speedrun, got busted, restarting stream. Okay, well, this was not a great and ideal start. But hopefully, I'm just going to delete this old one. That was a massive fail. But hopefully people will find their way over to this. I might just leave it for a moment. Okay. Yeah, I know. Got it working. Thank God. Get everyone on the other stream over here. That's not great. Might just wait a moment. Because, yeah, things have not gone to plan, to say it lightly. Not exactly the most ideal scenario. Yeah, with the stream crashing instantly, but that's fine. We'll just deal with it. I'm just gonna wait for a few minutes. I'm gonna wait 5 minutes for people to join if they wish, because the other stream crashed. Yeah. But in the meantime, what does the paper look like? Interesting. Okay. Very strange. Very strange. I don't know why it wasn't working before. That was quite annoying. But I might just. Stream health is excellent. Alright, I might just go for it. Seems good enough. There's 4 viewers currently, but it's annoying that the stream broke. Okay, let's start off. Yeah. Wait, is this the Alex or the other touch guy with physics? Okay. Okay. I don't know what Nico's doing. He might call me, but all goods. Right, let's get going, shall we? There's 6 people, concurrent viewers, so I think we should be fine. We got sodium hydrogen carbonate and citric acid being dissolved. So this is like what, Barocca or something, yeah? Just mix the condensed tablet. Okay, decrease the temperature. Okay, so that's like negative entropy of the like surroundings. Discuss the entropy change. Include a balanced chemical equation in your answer. What? So it's going to be something like NaH CO3 plus H3, and then the citric part goes to the salt will be like I suppose the acid. So I suppose the acid donates all its protons, right? So it's probably like something like Na3 citric solid. Citric. No, it's gonna be aqueous, right? Because it's in water. Aqueous plus somewhat the CO2 plus like water. Yeah. So we're gonna have to like balance that garbage. Oh, what's going on here? What the heck? interesting. I might just close Discord for the moment. Okay. Balanced chemical equation. Well, I need like 3 of these guys, yeah, so that's gonna add, so that means I need 3 of these guys. And that means that's like 6 hydrogens, so I need 3 waters. So it's 9, 3, 6. Yeah, beautiful. Okay, that works. And then I guess you just say something like the system has a positive. Why is texting me? The system has a positive entropy change since since 3 moles of since solid tablets produce 3 moles of very disordered gas as well as liquid water, and hence the disorder and randomness of the system increases. The surroundings decrease in entropy as heat is withdrawn from them, hence their dispersal matter and energy is less, so they experience a negative entropy change. The system has a greater change than the surroundings, hence spontaneity. I buy that, to be honest. Sounds good enough to me. It's a shame the stream crashed at the start, but you know, whatever. Guess we're just gonna have to live with that one. Okay. Let's see. Explain my reactions only observed once the tablet is dissolved in water. Well, I guess the answer here is in water the tablets can dissociate freely and hence exchange protons in the acid-base reaction. This isn't viable for them in solid form. Since they can't come close enough to react. I don't know, I think that's round about right. I seem to buy that. I should say, I haven't put the updated rules on here, have I? The rules are, play along if you want, every time chat corrects me, yeah, activation energy is a good shout, actually. Every time chat corrects me, I have to drink. Every time I skip, I drink. Every time I spend more than 8 minutes on a question, I drink. Activation energy is not the worst shout, actually. But, I mean, I probably just ask my dad, to be honest. He's a chemist, but yeah, I'll put this down in a text box with a little question mark. Perhaps water is a catalyst. Lower activation energy. I'll put a little question mark there. Someone from chat can tell us whether that's correct. What the fuck is this? I don't really want to be watching the stream live. That's probably going to draw too much internet, but whatever. Pure bromine trifluoride. Oh, can I change the resolution to 540p? No, I can't. Okay. 2BRF3 to BRF2. Shapes and bond angles for the 4 different. Okay. Interesting. BRF2 minus. Well, I suspect that will look like that with. It's 20. So 22. I suspect that's probably going to look something like. And that's linear, and it's got 120 degrees, 90 degrees. I think BRF4 plus will have 34 electrons around it, so that's just one up here, and then something like this. So that's a seesaw with 120 degrees and 90 degrees. What's chat doing? Not much. BRF2 plus will be something like 21, 20, so BRF2 plus 20, so only two lone pairs, right? Should be tetrahedral in some respects. Does it make it linear? No, it's not linear, right? Oh, it'll be bent. It'll be bent. I'm selling. Oh, whoops. Yeah. It's like water. Bent. 109.5 degrees. And then BRF1 minus 36. So that's 4 extra, so. And that's square planar with 90-degree bond angles. Sounds about right to me. Actually, I don't want to be loading this in, to be honest. Each reaction involves the transfer of a fluorine ion. Justify which reaction is more likely to give the ions responsible for conductivity. What? What? BRA. That's kind of code. What? Hang on. So it's like BRF3 plus BRF3 goes to BRF2 minus plus BRF4 plus, or BRF3 plus BRF3 goes to BRF2 plus BRF4 minus. That's 2. And it's probably to do something to do with fluorine. Huge. Thanks, Nico. If more electronegative, so likely to... Oh wait, Nico's right here. Hang on. Let's get him in the call. I don't know how the internet's gonna fare. The internet may not be great. I can,
Where,
hello?
hello?
Hello, okay. I thought my internet was going to give up
Hello?
there for a moment.
Where are you? What's going on with the internet?
It's not great. I'm at home and it's raining.
Oh, it's just suffering.
It's
Oh,
just suffering, yeah.
I see.
It's unideal.
Do you want to screen share temporarily? I
I,
can't stay for too long, but I'll
yeah, I mean, I honestly, if I
hang
screen
around.
share, it's probably just going to, like, crash the whole...
Oh, okay. Yeah.
Yeah. But what do we reckon? So you're saying the fluorine ion has something to do with it? Like, if more
Now,
ligature...
because like the uh check your thing. Because like the you're ripping apart a fluorine atom off the Br3 and chucking it onto the other one, right?
Mm-hmm.
So because F is more electronegative than bromine, surely that means F will be the one that's more likely to grab the electron pair, right?
Yeah, okay. So, yeah, I'll write that in.
So the negative charge should be the one which I I think I don't know. I don't know what they want to say. What they want to say.
Wait, so which one... Wait, so which reaction's more likely? Like,
Well, probably reaction
reaction...
number two,
Yeah,
right?
reaction 2,
Because
yeah.
whichever, because the fluorine dips and then takes
Yeah.
with it a negative charge and then chucks it onto the four.
Yeah.
So I feel
So
like
BR
I don't know what else could they want
F4
to say.
minus. Since the line takes, yeah, takes it with it, sort of thing. All right, yeah, no, I buy that. That makes sense. I mean, how long can you stay? Because if you're not gonna stay, if you're not staying very long, then we may as well just like give up because it's probably gonna buffer the stream.
Oh, you reckon?
Yeah.
Give up? Wait, what?
No,
Oh,
like give up on the voice call.
oh, okay. Yeah, sure.
But I mean, just call from afar and chat. Actually,
Yeah.
promote your promote our race on Thursday or whatever.
Oh, yeah.
Yeah.
There's gonna be a scholarship calculus speed run taking place on Thursday. Goodness knows what time yet, but
I'll be
it
running
will
this
be
in
done.
chat
It
too.
will be done. I am I'm yet to investigate the streaming rig options. I think it might be smart to
Yeah,
download OBS or something.
yeah, do something. I use XSplit.
Um, yeah,
Okay.
XSplit.
Uh,
Yeah. So hopefully that works. And yeah, I can't stay for long. In fact, I should probably have to go. But
okay. Well, ciao.
good luck with your suffering
No,
in
it's gonna be fun.
Skull Kim.
All right. Ciao. All right. We're fine. We're fine. Oh, we didn't need help anyways. Trust, guys. Trust. Um. Okay. So BRF3. So it can be T-shaped or trigonal planar, right? Wasn't this? I'm pretty sure this was a question on level. Um. So that's T-shaped, right? Or you could have um. You could have this going on. So I think this is the one that occurs. Uh. You know. Um. X minimizes potential energy in the atom. Recall, not in the atom, in the molecule. Recall that lone pairs are held closer and repel more than simple covalent bonds. Thus, trigonal planar would have a greater sort of unstableness with the lone pairs up and down, T-shaped better if the lone pairs are all in one place. Polar since asymmetric. Blah blah. Level 3. Yep. I reckon we're all good with that explanation, to be honest. What does open widget mean? Hopefully the stream isn't buffering too badly. I know it's not great, but it should be fine. Okay. Oh no, what's going on here? Well, let's see. 25 mils of ethylamine, to which nitric acid was added. Equivalence point was this. Predicted curve. Oh, it's down there. Okay. That's the pKa. The volume of this was 34.98. Well, I guess you could start by saying 0.1300 mole per liter times 34.98 times 10 to the minus 3 liters is 0.00454 mole of HNO3. Is it saying that that much was the amount needed to be added? I presume. Like that's got to be the answer, right? How bad is the stream doing? That's fine. That's gotta be it, right? And so the reaction, it's, yeah, 1-to-1 reaction. So initial moles of the base, which of course in this case is CH3, CH2, NH2 equals 0.00454. So the initial concentration CH2 H2 equals 0.0454 mole divided by 25 milliliters, so 25 times 10 to the minus 3 liters equals 0.1819 mole per liter. Hopefully that's the answer. Righto. And then the initial pH would be something like, well, there's a few things you could do here. So like PKB equals 14 minus PKA, so that's 3.36. And then KB, of course, will equal 10 to the minus 3.36, which equals 4.365 times 10 to the minus 4. So the concentration of OH minus, it's all coming back to me now, equals the square root of KB times the concentration of the base. So that's that times that, which comes out to square root of 4.36 times 365 times 10 to the minus 4 times the base 0.1819 comes out to about 8.91 times 10 to the minus 3. So the POH is negative log of this. Negative log answer 2.05. So the initial pH is 11.95. I buy that. Hopefully everyone else buys that as well. So initial pH is 11.95, so that's going to start up about that. So at halfway to equivalence, at halfway to equivalence, the concentration of the base equals concentration base is conjugate at halfway, right? It's the perfect buffer, so the pH should equal pKa, which equals 10.64. So that's it. Halfway to equivalence point is like, what, 17.5 mils or something? So that's something like around about there. And we're at like 10.64, something like that. Okay. And let's see. The volume of HNO3. So carry on. The pH has 20 mils of excess added. Excess. pH at equivalence. Well, I mean, at equivalence, right? At equivalence, I mean, that's the halfway point, right? So all the initial base has been converted to its concentrated to be the conjugated acid, right? So, there's 0.00454, I think it was 7 moles of the acid. Moles of, that's the wrong diagram to draw, of course. Moles of acid. And the total volume is 0.05998. So that implies the concentration of our acid is 0.0045447 divided by 0.05998. So about 0.0758 mole per litre. Are we buying this? Hopefully we're buying that. Alright. And then 0.0758 mole per litre. And then that's fine. So and then yeah, and so then Ka of course is 10 to the minus pk, so 10 to the minus 10.64, and that means that the hydronium concentration is the square root of Ka times that of the acid. So that's fine, so that's the square root of 10 to the minus 10.64 times the concentration of the acids is 0.0758. So we get about 1.3177 times 10 to the minus 6. So the pH is negative log of that answer, and that gives 5.88. I think I'm just checking that I'm doing this correctly. Well, and then in excess, oh, that's at equivalence point, so that's, what was it? 34 point, that's about 35 milliliters, and it's 5.88, so it's going to be like there-ish. Yeah, okay, and that's fine. And then after 20 milliliters of excess acid, well, the total acid volume is it's the number of moles. Excess acid is equal to 0.13. That's the concentration, right? Times the total amount of volume now, which is 0.05498, minus what was used up, which of course was 0.00454. Right, so that's 0.13 times 0.05498 minus 0.00454. So that's 2.6074 times 10 to the minus 3 moles. And then, so concentration H3O plus equals that number, 2.6 times 10 to the minus 3, out of the volume, which is of course now 0.07988. 7998 liters. So that's 0.0325 mole per liter. And if you put that into your calculator, you get a pH of about 1.5. So pH is 1.5 at a volume of 54-ish. Turn about here. So it's going to look something like this. I don't know. I buy that. Sounds about right to me. 18 mils and 28 mils. So at 18 mils, well, I mean, calculations are not required, right? Buffing capacity against. Okay, so 18 mils, the concentrations are roughly equal of the acid and conjugate base in the flask. This is good. This is good for buffering as plenty of excess acid and base is available. At 28 milliliters, this is getting close to equivalence, so not as much. What's being added here? Acid's being added, right? So we're taking away base, so not as much base is available as would be desired. Hence, strong acid additions would be more detrimental than strong base. I reckon we're going with something like that. Sounds fair enough to me. Oh, huge, we're done. Okay. A common equilibrium distribution classroom uses a solution made when cobalt 2 chloride has been dissolved in hydrochloric acid. What the fuck? The solution is purple in color when it contains an equimolar mixture of two complex ions. COCl42 minus, which is blue, and that which is pink. Write a balanced chemical equation for this equilibrium system to explain what we observed at either of the... okay, so it's going to be Le Chalais' principal question, but we need to have a think about what's going on here. So it's hydrochloric acid, and we've got... So that's really just Cl minus and H plus in solution. So on one side of the equilibrium you have like that one, and on the other side of the equilibrium you have that one. And then, so I suppose the missing factor is on this side you need 6 waters, and on this side you need 4 Cl minuses. Oh, and the charges balance. Yeah, no, cruising. Alright, that works out, I think. Okay, so, well, it's pretty simple, right? If HCl is added to excess Cl minus anions drives equilibrium to form more of the left-hand side molecules. So that would the solution would turn more blue. If solid AgNO3 was added, AgCl would form a white precipitate using up Cl anions drives the equilibrium to form more of the right hand side molecules, hence the mixture turns pink. I think that's about right. Don't know, sounds fine to me. What do we reckon? Chat's not really going up. Like, do we not have Hamish Bell in the chat from last time? That's sad. Sounds about right. I mean, I'm not obviously going into long answers because that can't be stuff, but that's the idea. Cobalt chloride paper is prepared by soaking pieces of filter paper in pink coloured and drying the paper. Paper becomes dark blue in appearance once it is dry, and it can be used as a chemical indicator. The paper becomes dark blue in appearance once it is dry. Why would that be? I guess because the equilibrium will start trying to make as much water as possible, so you get this. That makes sense. Alright. Predict which chemical the paper can be used to test for and justify your prediction. What? Acids or bases? Why would acids or bases do anything? Well, I guess the proof is in the pudding here, right? Proof is in the pudding. It tests for moisture levels. For moisture levels, the color change becomes more pinky as the piece of paper starts to rehydrate. Drives equilibrium to the right hand side. Hence, a color change indicates a more humid environment. Environment. I buy that. It's actually going so well. This is going well, yeah. Bryce said it could test for water. Yeah, nah. I mean, I'm pretty sure it's water. Like, who knows? I spelled environment wrong. Drink. True. True. Anything for a drink. Oh, I've got to get through this whole thing, man. I have a whole scrumpy. 8 standard drinks in front of me. How badly did I spell environment? Enviro... What? Oh, there's an N. This is what you do for fun, yang. Yep. Sad, isn't it? This is going amazingly well, to be honest. Yeah. What does the little what does this mean? Oh, top fans. I have no idea what that means. If someone could explain that to me, I would appreciate. Yep. Test for water. Good enough. They'll know. They'll know. Oh no. No. Okay, it's chiral. Okay. Wait, this isn't bad at all. This is way better than last year. So that... Okay, so it can't be just a straight chain, right? It can't be a symmetrical one. 4 peaks, so it's probably something like... No, that would be 2. Wait, no, hang on. Does this work? Because, no, none of them are chiral. No, that doesn't work. Okay. What about... Oh, wait, huge. This works, right? There's our chiral carbon and then there's 4 groups. I think that's right. That's compound A. What high school did you go to? I went to Hillcrest High School. Hamilton. But go to UOA. Yeah. I forgot an H. Where? Bollocks. Alright, is that a drink? I can't even spell drink. It's probably worth a drink. What do we reckon, chat? Okay, so I'm presuming we have to like write down all the things. Okay, so we send this through and they're in the second NaOH alcoholic. So that creates alkenes, right? So there's two options here. It could become. Zoom in a bit more. Oh, I can. Okay. It could become. The major product would be the one where the double bond goes this way, right? So H H H C CH3 CH3 H. Yes, that's the major. And the minor product would be the one where the double bond goes this way. No, 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 fuck. Fuck, fuck, fuck. No, that's wrong, that's wrong, that's wrong. That's the minor, that's the minor. Carbon with the least hydrogens versus another. Huge. Okay, I saved myself, I saved myself. I got 25 out of 32, which was O. Kind of fool says, what is this? Well, don't know. Don't care. That goes there. CH3, CH3. No, wait, wait, wait. I'm selling. Hang on. Minor. That's the major product. Right? Am I an idiot? Hang on. Carbon with the most amount of hydrogens keeps it. Yeah, that's the major product. This is the minor. This is the minor. Fuck. I'm stupid. I reckon that's a drink. Is Chem easy in level 3 compared to level 2? Aqueous systems, like the chemical reactivity, takes a big jump. But, I mean, the other two are like reasonable continuations, to be honest. Let's be honest. So that's fun. These two look fine. Dilute H2SO4. Oh god, so it can create 4 different things here, right? So H2SO4. This can make. Oh, Jesus Christ. Okay. No, it can't be 4 different things, right? It might be an overlap. Kind of rough. Kind of rough. Very rough, in fact, is how I would define this question. Just not as in conceptually, I just think it's annoying to write everything out. But that's fine. Did you get any other outstandings? I got physics, top scholar, and 28 on stats, and 1 off on calc, ESS, and ESS. For I think 4S, 3O, 3O. Okay, this guy reacts with H2SO4. Wait to the stream, wait to the stream. And if that guy there reacts with it, the major product is the one where the guy with the most hydrogens gets another one. So that would be where we have. That's the CH3. This guy claims another hydrogen for himself. And then we get that there, so that's the major. And then the minor product is where it goes over HHC. So our OH group is going to be added on to this guy there. And the carbon with the least hydrogens gains a hydrogen. Yeah, so that's the minor product. Okay, and from here, this guy reacts with H2SO4, and the major product is the one which creates this. I think. Level 2 to level 3 physics. 2 to 3 in physics is bigger than 2 to 3 in chem. Apart from waves. Okay, so this is the major product. It's got the most hydrogen, so you gained another one. And the minor product is the one where the OH sits on this group. Some of this. Right. Jesus, okay, we're making quite the mess. Certified potassium dichromate. So that can make three things, right? We've got three different compounds. We've got this guy, and this guy, right? Because this one here and this one here are obviously the same. Right, these guys are equivalent. This is going to oxidize, right? And so the first one, if you put this guy in, you get a carboxylic, oops, C double bond O, carboxylic acid. Carboxylic acid. This next one you get a ketone. Yep. This creates the ketone. That doesn't do anything. CH3H, CH3. And then the last guy, this one here, creates nothing. That can't react. Yeah, no, that can't react because you can't get a double bond on there. Oh well. Reinforcement HCl concentrated. HCl, so that would create the acyl chloride. And over here, oh. Plus HCl. Anyone? What do we reckon? I don't think that does anything. No. How many drinks have you had? Oh, 3 standards so far, I'd say. 3 standards so far, in about an hour. I've been sipping as we go. Are there 18 views? Holy fuck, okay, the stream's going. That's insane. What's the latency on this thing? Oh, okay. 3 standards so far. I mean, as much of a mess I've made. I would like someone to just clarify this part here. If anyone in chat could do so. Chloroketone reaction. I hope that's a joke, because I don't know the chloroketone reaction. I'm trying to think, like, does an alkane... Can you react an alkane with, like, HCl and get... Oh... I know like bromine water does it, right? Like bromine water and an alkane creates halo alkane with like UV light or whatever. Uh, uh-oh. 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 Oh, wait, because you're left with this, right? But you're also left with what didn't react. This guy didn't react, you know? Doesn't react. Is that correct? That must be correct, yeah. This guy doesn't react when you chuck chromate in because it can't make the double bond. It's already bond. It's a tertiary alcohol. So that guy's just gonna sit in the flask because all non-organic products were removed. Left uns. Yeah, okay, that's fine. So that stays. What else stays? Everything else reacts, I think. Yeah. All right. Uh, the OH peak. Um, the what is this? Butane, butanol, two two methyl, the two methyl but one ol produces the OH peak in IR spec. So that's the one where it's like something like this, right? The other doesn't. I buy that. Sounds about right to me. My entire form from the last question was different. My entire A from the last question was different. Am I cooked? I'm gonna say you're pan fried. Oh wait, and we need CNMR. This guy has one, two, three, four unique environments. This guy has. I mean, CNMR is not going to be much use in terms of environments. I guess like the CNMR can go away since no one knows what it does anyway. If someone, oh, is my mic really quiet? Okay, maybe I'll talk. I'll talk about that. I'll talk about that. We're all good. We're all good. Maybe I can turn this up. No. You might just have to turn the volume up on the stream, or maybe I can try to tilt my microphone closer to my mouth. Something like that. Maybe that might be a bit better. I can't tell. I'll just talk louder. It's fine. Um. So CNMR, yeah, no one knows how CNMR works, as we well know. 10 out of 10, exactly. Yep. CNMR is a hoax. Thank you. That's a bit better. Okay, good. Yeah. I think my mic's just bent a bit. I bought it in 2018, so it's not really surprised that it's broken. Oh, I need a periodic table for this, don't I? Periodic table. Alright. The lightest element with one electron in the 1s orbital. Oh, right, it's done before me. Found a period 2, this element has no paired p electrons and does not follow the general ionization. Wait, isn't that like oxygen or something? Yeah, because it goes like up, down. And can we just justify that? Well, at least oxygen's 8, right? So what's that? It's going to be 1s2, 2s2, 2p. Oh no, wait, it's nitrogen. Is it nitrogen? What do you reckon? Nitrogen? There's no paired p electrons because it's 7, right? So they're each just going to sit like 1, 1, 1. What do you reckon? How'd question 1 go? It's B and BE. What? Really? Oh, wait. Wait, really? Are you sure? It's boron. Oh dear. Oh dearie. I'll take you guys' word for it. I reckon that's a drink. No paired p electrons. I'll be honest, guys, I've forgotten what that means. So, what we're saying, it's boron. Wait, do they go in pairs? Am I an idiot? Maybe I'm just an idiot. Do they add in pairs? For real? Okay, nice. Thanks for your guys' support. Highest ionization energy. You go to the gym. Element is the highest ionization energy of any element. Is it like fluorine or something? How does ionization energy go? So, surely it's just fluorine, right? Fluorine seems to be the one to go for. Hang on. So, let's think about this. Ionization energy. If the radius decreases, the ionization energy increases, right? Now the radius decreases across the period, so the ionization energy increases across the period. So therefore it must be F, right? Yeah. Hang on, I mean, element with highest ionization energy. What do we reckon? Oh! Uh-oh. We could be in trouble here, gang. We could be in serious trouble. I'm not entirely sure. Um, Helium. Uh, oh dear. Well, it's another drink, lads. We're halfway to the bottle now. Lads and ladies, of course. Um, Helium. Alright. Ions of this period 3 element have the smallest ionic radius of all ions in the period. So that should be... Helium is smaller radius and more protons than H. Yeah, no, okay, I buy that. I'm just an idiot. Period 3, smallest ionic radius. That must be right at the end, right? Argon. Are we happy with argon? Gotta be argon, surely. Surely. I don't want to drink again. Like, it's like had half the bottle and like not half the bottle, but like a decent amount in the last 10 minutes. The highest bond enthalpy of any of the diatomic molecules. No, it's aluminium. Excuse? You put sodium. Smallest ionic radius. Nah, it should be the end of the period, mate. Because as you go across the period... Oh, sorry, as you go across the row or whatever... Period... Wait. Hold on, is period going down? And row... Oh, man. Autumn to rose periods. Okay, yeah, never mind. No, because Na has the largest. Because as you go across, you add protons, and they sort of strict in. Al3 plus. Al3 plus. Rubin folds has the least occupied energy levels and more protons. Ions of this period. Oh, it's ions. I thought it was just the atom. Yeah, you're so right. It is Al. Yeah. So right. So right, so right. It's not going well, gang. AL, AL. Okay, we're fine, we're fine. I've got every single one wrong so far. It's not going well. Diatomic molecule with the highest bond enthalpy. Surely it's just like fucking fluorine or something, right? Oh, is it just F2? Please tell me it's F2. Please. Please, I am begging. Surely F2, right? Is it gaseous dye with the highest bond enthalpy? Ah, but nitrogen can form N double bond, N triple bond ends. It could be nitrogen, right? Oh yeah, so even used to that. So yeah, N triple is sus. We'll put a little question mark there. Maybe we'll come back to it. For 3 of the elements you've identified, discuss which choices with clear references to just providing descriptions. Well, it's not really going to be my choice. It's your guys' choice. B. This guy is 1s2, 2s2, 2p1. No pair. P electrons. And does not follow the general ionization trend. Well known. Does not follow trend. I'm gonna hope that's true. Let's go for element HE. Top right of table. Smallest radius. So that means they must have the highest energy. Hey, Dad. Does helium have the smallest radius of all the atoms? Well, I'll hope it's true. He didn't respond. That's unfortunate. And charm table language. Yeah, maybe I'll write with. Well, neutral hydrogen still has a radius. It's got an electron flying around. Yeah, whatever. Yeah, I mean you have to pick. My dad's a chemist, by the way, chat. You have to pick like elements which match descriptions. It says the element has the highest ionization energy of any element, so presumably smallest radius. Chat wants me to give you a drink. Do you want a drink? He said no. It's unfortunate. Surely getting Dad to help is a drink. Okay, it's getting poor. Does not follow the trend. Highest ionization energy. The next element, well, we weren't really sure about this one, so let's go for this guy. Al. Who got this right? This was Ruben Folds. And maybe I'll type this out. As per Ruben Folds, 2025. Oh, we got to reference this properly. Et.al 2025 has the least occupied energy levels. Al3 plus has the least occupied energy levels, and hence, what were we looking for? Smallest ionic radius. Oh yeah, and hence smallest ionic radius. Hooray! Ruben Folds is the new Hamish Bell. For real, for real. Where's Hamish Bell? He didn't show up. That's so sad. That's actually tragic. Hamish Bell did not appear. By the way, whenever I type, my G and P keys double click. It's not that I'm completely wasted, it's just that it double clicks. That's why. Yeah, he's studying. Yeah, what a loser. Imagine studying. Alright. Oh, we're on to question 3. Huge. What time are we making? Oh man, it's been an hour and a half. Okay, it's not good. We're only just on time. Holy Jesus. 2.691 grams of that. Measurements. Measurements are shown in the... Holy... Oh wait, so we've defined the title, right? So that's 16.55. 15.8. 15.7. 15.7. 22.25. Hmm. 40.6 minus 20.7. That's 19.9. And 19.75 minus 0.25 is 19.5. Oh. Why do you type in chat? Well, I don't know. Oh my god, it's Hamish Bell. Oh, he's here. Well, I don't know what the stream delay is. Uh, I'm gonna type. I'm gonna type this in chat, right? And I want you guys to respond as soon as you see it, and then I'll know how long the stream delay is. So just respond as soon as you see that chat, like what I just messaged, and then I'll know how long the delay is. Just type anything, an E. Okay, it's only like 10 seconds. Fuck. Okay, that's fine. Crap. All right, that's fine. Pretty much no stream delay, so I won't bother typing in chat as much. Um. Right. Okay. Well, so the reaction here that we care about is HCl carefully nitrogen provided. So the reaction we really care about is something like CO3 2 minus plus 2H plus creates water plus carbon dioxide, right? That's something that's sort of what we're looking at. Yeah. That's really all we care about. Um, so the number of moles of Na2CO3 is equal to 2.691 grams. What's that, right? Yeah, 2.691 grams divided by of the molar mass, 106 grams per mole. So that's about 0.0253868 moles. Okay, I guess that's a good start. So, the concentration of this guy is that divided by 250 milliliters. So 0.0253868 on 0.25 liters. So yeah, that's 0.101547 moles per liter. Okay, I guess that's useful. So in a 10 mol alquat, you could say the number of mole in 10 mils is equal to the concentration times 10 milliliters. So I mean, it doesn't take a genius to move the decimal point a little bit. So it's 0.00101.547 moles. So what now? Hamish Bell is the legend. What have we got, chat? We've got half the bottle left. Okay, I'm gonna fill my cup up. How we go? Oh, Hamish Bell, you're going for calc. Interesting, man. I did calc in year 12, and I got S, got an S mark, and I was like so happy with myself. I did it in year 13. I was serious. I was going for top score, and I got so screwed over by the paper, man. Like, it was all geometry and bullshit and garbage. And I only ended up getting 27, which was not outstanding. I was very, very sad. But such is life. Hamish got scholarship last year in year 9. What the fuck? What the hell? Okay, that's just crazy. Okay, so Tim Arquette, and then I guess the thing I realized at the start was this guy it's a 2-to-1 reaction, right? So like something you could say in this to that point is um one lot of Na2 uh CO3 requires 2 HCl. No, it's a 2-to-1 reaction. Thus, number of moles of HCl needed is twice this, right? So times that by 2, you get 0.0203. Right. Yeah. Yeah, sadly not outstanding though. 1 mark off. Bruh. No swearing, not appropriate for dear Hamish. Nah, if Hamish Bell can get out nearly outstanding on a scholarship exam in year 9, I think I think he can be exposed to swearing pretty safely. I mean, what do we reckon? What do we reckon? I think that's pretty fair. That seems pretty fair to me. Not gonna lie. Like, nothing wrong with that. You know, say the word fuck. Who cares? Um. Okay, so that's fine. Um. Uh. Okay, that's just sort of like reference data. The student A data. Um, if we take these guys, right? That was just a rough one. The mean titer value is 15.8 plus 15.7 plus 15.7 plus 15.65 divided by 4. It's about 15.7 student A. So the mean titer was about 15.7 milliliters. So times 10 to the minus 3 liters. So I guess that would mean the concentration of HCl for A was equal to the number of moles. Number is 0.02031 divided by so that's about 0.002031 divided by 15.7 times 10 to the minus 3. That's about 0.1294 mole per liter for student A. I'm going to assume because chat... Oh no, wait, do people have my Instagram? Yeah. Wait. Oh, yeah. Fuck. I noticed random people started wanting to follow me. And I was just like, okay. Uh, people. My Instagram page for reference, if you want to follow it, it's Alex underscore Madison. My profile picture is like a guy holding a fish. I was like 10 years old. Half my posts are because I promised in year 12 that I would bake my cohort cookies if they voted me for head student. Um, well, I mean, he is a random person. I don't know him, but it's still like I'm honored. Like, nice on you. I know the law, mate. Okay, I know the cookie memes. Wait, wait. How do you know that? Anyway, I promised my student cohort. Wait, random people are requesting to follow me on Instagram now. Who's Scott? Who cares? Um, but I promised my cohort that I would bake cookies if they voted me to be head student. And unfortunately they did, and so I was head student for a year. Um, and I had to bake cookies for everyone, so that was great. Yes, the reel about chemistry marking is glorious. I would recommend watching. Go follow my Instagram. It's Alex underscore Madison with the picture of the kid holding a fish. Okay, anyway, so that's student A's concentration, and then for B, actually, I might just go to the. No, I don't need to go to the bathroom. I'm just gonna go to the bathroom. For student B, I guess we can take all of those. Look alright. So 20 points. The mean. So the mean titer is about 20.038 milliliters. Righto. Which means that the concentration for B is something like 0.002031 of the moles out of 20.038 times 10 to the minus 3 liters, which is 0.02031 on 20.038 times 10 to the minus 3, about 0.1014 mole per liter. So, same order of magnitude. They're not terrible, but what did the teacher put? 0.1040. Teacher equals 1040. So that's yeah. Who knows? Um. So like, I guess this is where you like just use your level 2 titration skills. Student student A is a bit off. Causes of error. Parallax error from reading burette wrong. Not cleaning glassware. Glass with distilled water. Being an idiot. There's a few things which could go wrong on this one. Just a few, just a few. Chat. I'm just gonna go to the bathroom really quickly. But if I go to the bathroom, I'm gonna lose ethanol from my body, and that might not be very useful. What do we reckon? What's chat's consensus? Should I go to the bathroom? Might not be wise. Who requested to follow me? Let's see. Chat is dead silent. Yeah, chat is dead silent. Who cares? Don't know this guys. I will be back in like 2 minutes. Enjoy the dead silence of chat whilst I am gone. Um, right. Yeah. Okay, I'm back. Ruben Falls. Catastrophic titrations are boring. Yeah, no, that's true. Alright, well, we can move on from that question. Oh, hooray, it's a more interesting question. Are we excited? Hopefully this was correct. Um, okay, let's have a look-see. Enthalpy change. Oh no, it's like level 2 bond enthalpies and whatever. Enthalpy of formation, enthalpy of reaction, specific heat capacity. Okay, so method 1. So this is like the level 2 method, right? Oh no, it's got Q equals mt delta T in it, right? So it's completely combusted by the student heat raised the temperature of the water. Okay, so yeah, okay, so Q equals mc delta T equals uh 300 milliliters of water, right? So 300 grams of water times 4.18. Oh, there's like some unit there, whatever. Remember, 1 milliliter is 1 gram of water. If you don't know that, oh dear. And then delta T is fucking that minus that. So 29.2, and that's 300 times 4.18 times 29.2. That's 36616.8 joules. Alright, so 1.35 of hexan 1-ol, 1.53 grams of C6H813 OH. To give you a molar mass, is the number of moles should equal 1.35 divided by 102.2 equals 0.013209 2094. Oh, what do you reckon? Yeah, in a separate, yeah. Unfortunate Rubin folds, yeah. Remember, Q equals MC delta T applies to just one thing at a time. Common mistake. Um, so this is kilojoules per mole, right? So, or joules per mole. So 616.8 joules per 0.0132094 mole. That's type this in. The heat produced, so there must be a negative sign, right? Just by convention. 2772 kilojoules per mole. Hopefully that's correct. Enthalpies of formation. Delta H equals delta H formation. So it's products minus the sum of delta H formation of the reactants. So that's the products are 6 lots of CO2. Yeah, so 6 lots of minus 393 plus 7 lots of water minus reactants. So that's minus 320. 902s. Wait, what? Wait, what? What happens? Where's the oxygen? Am I an idiot? Do we need these? Who knows the answer? Come on, someone knows the answer, right? Reactants. Oh, wait, that's already in its formated state, right? Yeah, because O2 is formed. So it's just this. Okay, so plugging that in, you get minus 4040 kilojoules per mole. Using bond enthalpies and enthalpies of reaction. Using bond enthalpies and enthalpies of reaction. Cook. Duh. Did not want to do that. Well, so you've got like a whole bunch of shit in there. And then this. So bond. The bond's broken is 5 lots of C to C. Yeah, because there's 5 of those in that chain. Yeah. Plus 13 CHs. Then there'll be a CO and then an OH. Plus 1 times C double bond. No, not C double bond, just CO. Plus 1 O to H. Plus 9 double bond O's. Plus 9 O double bonds. Well, okay, so, and then bonds formed. There's 12, yeah, 12 C double bond O's plus 14 OHs. So a bunch of adding we've got to do now, right? Bonds broken minus bond formed. Okay, stand by whilst I add these up. How does marking work for Chemsitry? Well, me and Nico, the guy who was briefly in the stream, we probably might. We actually record. Okay, so we recorded a video called the Scholarship Chemistry Marking Conspiracy, and we did really well on it. And we went into a bunch of graphs in detail about how they actually marked the damn thing. Unfortunately, I didn't record any of the audio, so we just scrapped the video. And we're probably going to redo it eventually at some point, and it will reveal all the secrets, as it were. It's quite interesting actually. They if I had to sum it up really quickly, answering it's quality over quantity. If you answer every question, but only to a basic standard, like you don't go into depth, you're only going to score like 5 for the section. However, say there's like 3 questions in one section. If you answer 2 of them to like an outstanding standard, and then just give up on the third one, you will still get 8 or 7, right? So it's quality over quantity. An example of this would be oh no, I can't find my paper on NZQA anymore. Last year's exam, I got like question 1, I got the entropy question wrong, but I still got 8 because I did really well on the other bits. So yeah. So this thing, I've just been putting this in my calculator. It comes out to about minus 3,000 ish. Kilojoules per mole. So this is a bit interesting. Well, I guess like the experiment will underestimate heat is lost to environment. Method two is method 2 should be reliable as it is theoretical. Method 3 is sus. I reckon that's good enough to tell you guys the truth. Well, I guess it's the fact that bond enthalpies, right? These enthalpies that they come up with, just magically, they're based over like many different compounds. So it's not very fair, I guess, to say that it's the same enthalpy for every compound. I think it might change based on the environment. Butanoic acid and ethanol. Oh, okay, so just okay, yep. Outline 2 different reactions that be used to prepare this ester in a chemistry lab. Rubin Folds, I like that. I mean, I don't know what the answer is, but that seems reasonable. Oh, so there's like the acyl chloride route and there's the carboxylic acid route, right? So you could go something like, so it's reflux with acid, and you have like butanoic acid So butanoic acid um, plus, yeah, plus ethanol, right? And that's what's that creates ethyl butanoate plus water. Comparing the experimental conditions and safety considerations for these reactions. We'll do that later. Two. Yeah, so you go with acyl chloride. So you could go butanoyl chloride plus ethanol, right? And that creates ethyl butanoate plus HCl. Yeah, but what you need SOCl2, right? So SOCl2 is toxic, which is not great, and HCl gas is, as we would say in the ed biz, no bueno. Yes, that's no heavy. And then this is obviously acid. Acid is no bueno for safety. I buy that. He's getting them correct too much. The drinking has decreased. The drinking has not decreased, mate. The bottle is empty. All I have left is what's in my glass. No, I mean like I studied like this is all just like locked in the back of my brain. I mean this question was not hard. Let's be honest. Um, I mean this question's kind of obvious, right? Like it's not too bad at all. Well that's distillation, and that's reflux. Um, Separation of ethanol and butanoic acid. Discuss what each effort used. Oh, acidic hydrolysis, yes, that require use. Okay. Well, the 2 is for reflux. This converts the ester back to ethanol and butanoic acid under acidic conditions and heat and reflux. You can say organic reactions are slow, hence reflux speeds them up. Then one can distill ethanol, and butanoic acid. I think, well, ethanol has a lower boiling point than butanoic acid. Butanoic acid's bigger and it's still polar, right? So you know, like distill at that temp, and the ethanol boils away, condenses on the glass, and is collected. Huge. I think that's good enough. Oh, and question 4. Alright. Good news. 11 likes. This is huge. It's really getting up there. I wonder what the channel analytics look like right now. Have I gained more subscribers in the past 5 seconds? Let's see. Huge. People subscribed for the video. What the fuck happened there? Oh, that was the physics. Righto. Oh, it's a Q equals KS question. Or Q is greater than KS or whatever. Ooh. Okay, so if we can, so we got, I mean, everything that's important, right? There's K plus, Cl minus, K plus, and CrO4 minus of an Ag plus and NO3 minus, right? Those are all the ions that we could expect in this question. How long do we have? We have an hour left. It's not really much of a speed run. We're just sort of actually doing the whole paper, but whatever. Right. Well, so it's containing that, and then silver nitrate keeps getting added. Okay. And right. And at some point, these solids start to form. Right. They can't do it any longer. Well, Ag plus times Cl minus equals the Ks of AgCl, which is 1.8 times 10 to the minus 10. The Cl minus concentration, now if we just keep adding that, is 1.39 10 to the minus 4 mole per liter, right? So Ag plus, I guess you could say this is at precipitation equals 1.8 times 10 to the minus 10 divided by the Cl minus concentration, which is 1.39 times 10 to the minus 4. Oh, wait, no, it's 1.68. Whoops. That's probably worth a drink. It's going to be a sell. How are there only 2 viewers? What happened? Exam fell off, man. Exam fell off. No one's interested anymore. So that's fairly easy to calculate. On a calculator, we get 1.07 times 10 to the minus 6 moles per liter. Yeah, okay. That's fine. And then for the other one, Ag2. Oh, so it'll be like Ag plus times CrO4 minus squared equals Ks. So Ag plus at precipitate equals the Ks value, which is 1.39 times 10 to the minus 4, divided by... Oh, wait, no, I need... No, wait. That should be squared. That should be squared. Yeah, that should be squared. That should be squared. It's that divided by the CrO4 minus concentration, which is 1.39 times 10 to the minus... Oh, no, that... Wait, what? Oh, wait, I'm selling. Things are getting poor. 2.6 and 10 to the minus 12, of course. This is not good. Everyone has left the stream. What happened? Oh well, who cares? That's 4.33 times 10 to the minus 4 moles per liter. Second solid begins to precipitate. Well, this one precipitates first, right? So AgCl precipitates first. seems good enough to me. Yeah, Ruben folds his server. Nah, concurrent viewers dropped to 0. He left. Oh well, I mean, for posterity, I will just keep going. Yeah, no, we were peaking before, but I mean, like, it got disinteresting as soon as aqueous systems started, let's be honest. Alright. So when uh so when the oh, okay. Right. So when it first begins to precipitate, when AgCrO4 begins to precipitate, the concentration of Ag plus will equal 4.33 times 10 to the minus 4. And at that instant, right, Cl minus equals Ks divided by that. And if you put that to your calculator, you get, oh, there is 5. I don't know what happened. Like, stream is glitching. Who cares? If you put Ks divided by that, you should get 4.16 times 10 to the minus 7. And that's remaining. That's sort of what's left. So the initial was 1.68 times 10 to the minus 4. So there is, as a ratio, oh wait, no. I mean, that equals about 0.25%. So I mean, like, that's 99.75% precipitated. And that's not enough. It's not. That's not enough. It is not enough. That sounds good enough to me. Yeah, that'd be useless. Terrible. Second experiments carry out. Dilute solution of that was slowly titrated into a beaker containing solution described at the beginning of part A. Oh, okay. Should consider the amount of. Oh, okay. So 125 milliliters of oh no, hang on. Wait, okay, this question's kind of rough. This question is very rough. Hang on, let me just get my calculator. So second participate forms when this is the volume. So solution. Oh yeah, okay. So that would mean that the Ag plus would equal, what was it? Yeah, 4.33 times 10 to the minus 4. I think. Um, hmm. So, like, total AG added equals moles used plus moles remaining. So, like, you could say, like, moles of Cl minus initially in the 25 milliliters. That would be what? So, like, 1.68 times 10 to the minus 4 times 0.125. So that equals what? 2.1 times 10 to the minus 5 moles? And then each of those consumes 1 mole. So, like, Ag consumed is equal to 2.1 times 10 to the minus 5 mole. What do you reckon? That's got to be right. So, moles of Ag plus left. Well, that would just equal the, like, the equivalence one times 0.125. No, at threshold. So that's 4.327 times 10 to the minus 4 times 0.125, and of course that equals 1.71 times 10 to the minus 5 moles. So the total's just these two added together, right? So 3.18. Oh no, so whoops. Dyslexic as fuck. 3.81, can't read my calculator, times 10 to the minus 5 mole. So, like, the concentration must have been that divided by volume. So 2.268 times 10 to the minus 3 mole per liter. What do we reckon? Oh no. Oh no. Oh man, I can't even see straight. Why am I doing this? Hmm. But that's not even gonna. Voltmeters of infinite resistance. Why would? Oh wait, yeah, never mind. That's fine. Um. So they couldn't justify them in terms of oxidation reduction process, flow of charge. Hmm. Hmm. Oh my god. No fucking idea, eh? Well, hmm. It's doable. So for the permanganate one, so you get something like MnO4 minus plus something or other. Well, I mean, we don't know yet, right, do we? So it's, and then you get Mn2 plus 4H2O. So what are we? So we're 8H pluses plus 5E minuses. And that's fine. That's for this one. And the other one, that's one. And then in the second one, you get something like Zn, Zn2 plus, right? Yeah, that comes from that. It's 2 minus. Goes to zinc solids. So it must be 2E minus. Yeah, it just forms solid zinc. Zinc solid. Yeah, okay. Rough, man. I haven't studied this in a long time. So that's being reduced. What's it oxidizing? Oxidizing some copper. Alright, so copper oxidized. The negative sign on cell to negative sign opposite direction. I'll be honest, mate. There's too many words in this question. I mean, this seems something like that, right? And then there's, in this one, copper gets oxidized to form the copper solid. No. Copper gets reduced. No, it gets oxidized. Oxidation is loss of electron. No. It can't get reduced. It must get oxidized. So copper solid goes to copper 2 plus 2E minus. So combining these two, what? So we get 2MnO4 minus plus 16H plus 10E minus goes to 2MnN2 plus 8H2O, and we also get 5Cu solid goes to 5Cu2 plus 10E minus. So what's this? So 2MnO4 minus plus 5Cu solid plus 16H plus goes to 2Mn2 plus 5Cu2 plus 8H2O. Okay, and then for the second reaction, the other half equation, so zinc's being reduced, so copper's being oxidized. Oh, so it's the same, right? What do you reckon, chat? About that, right? So the other, that's for cell 1, and then for cell 2, you get something along the lines of Zn2 plus copper solid goes to zinc solid plus copper 2 plus. and then you just say some like yap. So electrons go from anode to cathode. I think that's something that's true. Positive voltage. So that must mean that that minus that is 1.17. I mean, that seems fine to me. Oh, Rubin folds. Balanced equations is all we know how to do, man. Um, Phew. So cathode minus anode. What? So it's saying that let this be x, let this be y. So x minus oh wait no. Fuck. Cu2 plus Cu. Oh, that's at the anode. So something like fucking zinc. Okay, so zinc. So minus 0.76 minus x equals minus 1.10 and something like y minus x equals 1.17. Alright, I think. So you get minus 0.76 plus 1.1 y equals 1.17 plus 0.34 1.51 volts. I don't know, man. Oh, level 3 question. Level 3 physics question. That sounds stupid. Piece of zinc metal. So permanganate. Oh, we just worked this out, right? That was y. So 1.51 minus 6 equals greater than 0. So react spontaneity. Oh man, I'm just short. Whatever. Like, I'm sorry. That's kind of over on that one. Oh my god, what? Oh my god. Do you reckon they've released level 3 physics? Um, 91524. Pants. Can't get it. Is someone saying whether that's correct or not? No, that's someone else. Oh no, that's... You're talking about physics. Fuck. I actually don't know what's going on here, to be honest, that well. It's not my area of expertise. Uh, that seems very loose. It depends on a few things, and I'll be honest, I can't work it out. So, but this question is actually very interesting. Um, so I suppose, like, a good starting point would be to realize, like, NaCl has a one-to-one lattice structure. It's very, very symmetrically ordered. MgCl2 doesn't have this. Attraction is greater, I guess you'd say, is proportional to the product of charges. So in MgCl2 we have Mg2 plus and 2Cl minus. So this product is greater. No, two is clearly greater than 1, right? No. Whereas in NaCl it's just, Na plus Cl minus is just 1. 1 times 1. Hang on, let's look at a periodic table. Mg there. Na. Mg's after Na. Well, I guess you could also say that Mg has a smaller radius than Na. So it's like a higher density of charge. So that means that, MgScl2 requires more energy since it is more tightly bounded and held together. That's fun. Oh my god, we're done. Thank fuck. Physics is great and all, guys, but I think we're done with the stream. Well, we're not done with this. Well, depends. I can keep the stream going if you guys want to chat, lol. Wait. Wait, should I stream GD? Who would watch that? Who would watch if I stream GD? I'll beat an extreme demon. Geometry dash. Fire. Real, bro, real. I might download this and can I download this? Doesn't really matter. Downloads. I don't know how to download it. Stream GD. What was the answer for that last chem skull? I think it's this. MgCl2 requires more energy. Right, because MgCl2, like the Mg2 plus cations, like attract stronger. It's harder to break the ladders apart, I think, is the general idea going on there. Let's speed up geometry dash. It's gonna be far. I don't really expect anyone to watch this, but whatever. Oh, Skull Calc's gonna be interesting. Yeah, I mean, I won't have a chat. It's gonna be interesting. Skull Calc will be, I'm really interested. Oh, totally to plug. There's a guy who speedruns Skull Calc every year. He's still doing it, but this year, me and Nico are gonna go up against him in a race. Nico's the Speedy Memes, and we're gonna work together. Why can't I see my mouse? What? Okay, that's not ideal. And then I can't even. Here we go. Huge. I suck. Oh, fuck. Nah, chat. I'm not playing that stupid game. Rubbish game, man. Prime. Yeah, it's prime Alex Madison content. No, I'll beat Cataclysm real quick. Trust. That's what we gotta do. That's what we gotta do. For fuck's sake, why can't I see my mouse? What is this? So it's like bugged or something. I gotta like pull tab out, find the right area, and then go to Cata. Oh, that's not in there. Fuck. Cataclysm. Do you play RL or Fortnite? What's RL? Or Rocket League or Fortnite? Occasionally Fortnite. What happened with Curve? Top Skull, I can't operate computer. Mate, it's not working, man. Like, I don't know. Like, what are we talking about with the sus titration curve? I thought it was fine. Aren't we all good? Like, what's wrong with this? Seems fine to me. I'll just like, you can just pause at your will. There you go. Pause when you want to check that, and that's the curve. and then whatever. Should be sharp initially. Oh, I can't be bothered. Yeah, alright, sure. It should be something like Meh, if you really want to get technical. Oh, see now look what you've done. You've deleted the whole thing. We can blame Ruben, whatever his name is, for that one. GD, but every death is a drink. I like the sound of that. Let's do it. Okay, that's one drink. Fuck. Shit. Fuck. Screw this level, man. Why can't I actually don't know why I can't see the fucking... I need a level. Oh, wait, here we go. Jaw breaker. That'll do it. For those of you wondering what the hell's happened to the stream, I don't know. It has become a mess. I'm sure you can cycle back and find what you want. No, back here. We're gonna beat Jawbreaker. Thingy gold stream. I think I did all that. Oh my god. Oh my god, I just... Can I get past pre-drop or what? Holy shit, bro. Ah man, this game looks short and fucking... Look at the waves pulsing. Pretty short. Oh, I can't even get to the drop. I can't even get to the drop. I'm just that bad at the game. Here we go, guys. Here we go. Ah, no, I got halfway. So. Cell death. Why are people still watching at this point? I'm sure you can't hear a word of what the fuck I'm saying or whatever. No! Oh, it was going so well. Wait, the most crazy pull. B. B bloodbath. No, not on the start pause. On the real pause. There we go. Oops. I've decided I hate that level. Okay guys, I think I'm gonna wrap the stream around about now. I think we did pretty good. Yeah. Anthel cool, all I can say is, as the top physics scholar... Oh, wait, okay. Well, yeah. Can top physics scholars explain why this for weights in the international space station a little bit? Yes, I can. See you for Skull English Speedrun tomorrow? Absolutely fucking not. No way. Can top physics scholar explain why astronauts feel weightless in the international space station in orbit? Yes, I can. The feeling of weight comes from the reaction force, i.e. the ground pushing against you. When you are in orbit, gravity is fully being used up by centripetal force to keep you going in a circle, so you don't feel a push outwards. And then, and also, Aiden Park, you're right. Yeah, for Skull Calc. Now, importantly, guys, and I don't know who's going to be barely anyone's watching this, but spread this to your friends and whatever. It's very important. For Scholarship Calculus, I will not be streaming. Never forget the OGs that we have the GD stream that didn't work. Yeah, fair enough. Well, I mean, I could stream GD later. Maybe I'll do it on a separate day. I'll stream GD and we'll see who comes and watches, but whatever. Importantly, for Scholarship Calculus, it'll be on Thursday because the 2019 Top Scholar has a way of getting the paper. And he will be streaming it as a speedrun, but me and Nico McKinley, who was the Top Scholar for Calculus in 23, 22, and 2024. I know you got it in year 11, 12, and 13. He's crazy. Me and Nico McKinley will be working together to try and speedrun and beat him. So it'll be a race. So Nico will be streaming on Speedy Memes. That's his YouTube channel. But 180 subscribers or something. He'll be streaming on there. I'll be in a VC with him. And we will work together and solve it. Yeah. We told our math teacher about that too. About what? What are you telling your math teacher? The Skull Cut race. Oh yeah, it's going to be huge. Yeah. Oh, I mentioned the physics stream. Oh yeah, I mean I can't remember the physics stream. I was fucking completely gone. I mean I'd had about half the bottle of vodka before I started the physics stream. So you sort of know you're in trouble at that point. We have 5 people have added to the viewership. Once again, I mean like the actual chemistry ended about 30 minutes ago, and we're just sort of yapping about nothing. But yeah. What else can we do in GD? We're gonna be Bloodbath? No. I wanna get to like this shit. Oh god, I suck at this game. It's so hard. Why did it have to be so hard? That's what she said, right? Reckon I beat 9 circles? One attempt for being 9 circles. Whoa, what? I can't just hold it. quite like to get. I would quite like to get to the draft. Oh, fuck this. Stupid. Have you tried Osu? I have seen. Does he know it isn't working? What isn't working? Oh, does Genie not work? Wait, am I an idiot? Hang on. Oh, wait. Fuck. Why won't this stream? We can't see the gameplay. Oh. Well, that's poor. Ah. Okay, I will try and fix that actually. Let's try and fix that. I'm glad someone told me it wasn't working. Why is my mouse not on the screen, man? It's like it's botched. So you guys can't actually see what I'm clicking right now. That's unfortunate. Oh well. I was popping off, I want you to know. I got like 60% on Jawbreaker. It was going well. It was going well. I wonder why it doesn't work whenever you're streaming. Who knows? So whenever I click play on Geometry Dash, it just goes to nothing. Well, I'm not too sure what the problem there is. That's unfortunate. I might try and work out what the issue is at some point in the future. Aside from that, let me go through the gameplay. Like, how does that? Why? Why are we fucking it up? Yeah, I don't know. Who knows? If anyone works it out, please tell me. Okay, aside from that, Skull Calc, remember, I won't stream it. I will screen record it and I'll post it to my channel. But Speedy Memes will stream it. I'll put out like a post maybe or something. I'm promoting it. Speedy Memes will stream it. Who knows? Maybe I might stream it. We'll talk about it, but unlikely. He'll stream it, and I'll be in a VC with him, and we'll talk and discuss answers, and we'll try and beat Ethan, who's the 2019 top scholar, and we'll try beat him to the punch. Yeah, that'll be good. Does anyone have any final comments or questions or anything? Anything before we wrap up? I don't know why the gameplay for GD isn't working. It's rather annoying. Like, so you guys can't see. You guys can't see like I'm playing a level right now. Rather unfortunate. Yeah, I don't know why that is. I really don't know. It seems to be it's just chalked. But yeah, that's it. So that's the whole exam. What I'll do is I'll just very slowly scroll through, and you can stop and pause at will. Oh yeah, that was a bit of a mess. That, and then a bit more garbage. The precipitate question. That quiz is not kin enough. To be honest, I don't really know what it's doing here. That's fine. That's bullshit. And that's whatever. So I think that does us, guys. If you want to friend me on Discord, you can. I'm always keen to play games with people and help with physics and such. Um, that's funny. Um, my this is my Discord here. I'm also I'm John Physics in the NZ Create Discord. If you want to find me there, that works too. But yes, I'm gonna end the stream. Thank you all very much for watching. It's been fun. Tune in for Calc. Remember, different channel. Just search up Skull Calc Race, Skull Calc Speedrun, whatever. It'll be sorted. You'll find it. It'll be Thursday evening probably. Looking forward to it. Good night, and I wish you guys all the best in any further exams you may have. So, yes. Have fun, and I will see you later. Ciao.